So I have, with great pleasure, to introduce three of the most impactful neoclouds on stage for the first time ever. It's must-see TV. You're never going to get it anywhere else. This is where it's happening. I have Duncan Ng, Duncan Ng, from Solutions Engineer, VP at Vultr. Kyle Sosnowski, VP of Software Engineering at Crusoe. And man, it's my honor, CEO and founder, TensorWave here, Derek Horton. Give it up. All right, guys, so we're gonna whiz through this. I thought it was interesting. The world is changing. I was talking about it earlier this morning, but before it used to be about who can get the most GPUs and the fastest, right? And allocation was king. Not even 18 months ago, right? Everybody was lining up, and PO was, everybody was talking about allocation. Now, it's all about building these things at scale more efficiently and optimizing it. So I thought it would be great to have this conversation about building AI factories at optimization and scale today with you gentlemen. I was listening to the All In podcast, and Elon was on there, and he started talking about the human meat computer. And this biological brain that we have operating at 20 watts, and 10 watts doing administrative work. And so the other 10 creating humanity. So it leaves us, this gap. We're deploying, you guys are doing at 100 megawatts and beyond, just to do maybe what 10 watts could do in our brain. So lots of room for improvement here. And with that, I want to talk about building building the factories, right? And so Kyle, I'll start with you. You guys have a sustainability approach, right? Efficiency is at the core of what you guys are thinking about every time you build these factories. How do you balance that sustainability piece with high density GPU design?
Can you guys hear me? There we go. It's a good question. I think, our focus has always been bending the arc of energy towards sustainability. And it'd be a lot easier for us to just turn up data centers on any grid-connected site, fossil fuel sites, what have you. And we do the things that we do because they're hard. We aim for energy sources that are a mix of hydro, wind, solar, and we build these data centers to the best that we can to use those energy sources. And so, in terms of the actual density of the deployments themselves, one of the latest things that Crusoe has come out with is our Spark MDC. This kind of goes back to our roots as a Bitcoin miner that we started as 7 years ago, and then ultimately pivoted into HPC. And it allows us to build these modular data centers next to these stranded energy sources that are, be it flared gas or reclaimed batteries out in the middle of the desert, and allows for high density modular compute that can move to the closest points of the energy, and really lets us pack in data centers to the closest source.
It's good stuff. So, Derek, let's talk about building things. You guys have a co-design approach to what you're doing. Where do your customers feel that advantage in how you approach the design?
Yeah. Can you hear me all right? Is this working? How about now?
Yeah.
All right. Yeah. Excellent. So yeah, we have to work very closely with customers to build an environment that is ideally suited for their workloads, right? At the end of the day, there's a lot of common threads between different types of customers, different type of workloads, training, inference, fine-tuning, but often you can squeeze out more performance, you can optimize quite a bit by tweaking the infrastructure design and even the server design in some cases to be a little more well-suited for one versus the other. And that's something that you can only really do at scale. It's not efficient to do it for very small opportunities, but for larger customers and larger clusters, you can squeeze out a lot of additional performance by doing that co-design and optimizing for the particular use case, the particular workload, especially on the network side. On network design, the requirements and constraints for training or distributed inference or fine-tuning are all very different, right?
Great point.
Yeah.
So Duncan, You guys are doing it globally, man. And how do you keep the performance high while you expand your footprint? You guys are doing it a bit better than most, so give us some insight.
Yeah, for us, it's really a case of, we've been in this industry for 24 years. We've been deploying globally for, a significant amount of time. All of the kind of, legal and GA work that gets done ahead of time makes life a lot easier. But now taking all of the kind of things that we've seen in previous industries, Intel's concept of, design once, replicate everywhere, ideas that we also see, kind of optimizing the stack, from concrete to token, all of these different concepts, you want to kind of ingrain that into every part of the process. So being able to deploy globally is something that, our customer base has demanded from us from the get-go, delivering this capability, not just here in the US, not just as it grows in the EU. We were early additions into South Asia, into APAC, and into Australia. So definitely a case where being able to take that optimization mindset, both from a business perspective as well as a tech stack, physical perspective, and then into the software as well.
That's fantastic. That's at the heart of the issue. So now you mentioned scale. Let's talk about validating that, right? And that's the next wave. Musk also had this idea of distributed inference farms. I think he also mentioned it's like linking 1 kilowatt of inference power per Tesla at 100 million Teslas is 100 gigawatts of, idle inference power that we can do. That's validation, that's scale, that's where we really want to see the mass efficiency at. But, how are you guys ensuring global consistency? And I'll keep the question with you, Duncan, since we started. Global consistency with that performance delivery.
Yeah, so that really leverages kind of the experience that we have deploying, this kind of same control plane, replicating that in every different location, working from customers, whether it's someone who walks up with a credit card all the way to someone with $1 billion PO, we're leveraging and taking all of that additional learning and iteration and being able to democratize access to all of those different levels.
That's awesome. So Kyle, what tells you a cluster is fully production ready in the Crusoe ecosystem?
Yeah, it's a good question. And also to kind of build on what Duncan was mentioning there, like, federating our services across the globe to be able to allow for low latency and building on top of the acquisition that Crusoe did recently of Atero, and a company in Tel Aviv that is focused on intelligent management of memory at the inference level and less so the CPU bound stuff. And so, the bin packing for us is going to look at optimizations in the key value cache side, less so on just scaling out compute as immensely as possible. In terms of cluster qualification, when do we actually think that something's ready? We have a pretty rigorous process in how we want to validate a cluster, be it RICL or nickel testing and running PyTorch validations. There's a really excellent piece that came out recently on our partnership with PyTorch and how we've been able to qualify our clusters and make sure that we have the right quality before we hand those off to customers. And then the kind of ongoing progress that we're making there is infrastructure that's self-healing. So the hypothesis that we're making and what we're driving towards is that this battle is kind of won at the interface layer and the user experience layer. Less and less time that people are going to spend managing their clusters, and more time that these agentic systems and systems that we build are going to be taking care of that for you. So responding to XID errors, responding to issues with the hardware, and pulling out capacity and replacing it for you. So kind of self-remediation and self-healing infrastructure.
Man, that's value at a high level. So Derek, back to you. You mentioned tuning. I'm going to stick with that theme on this validation piece of it. You're talking about tuning and validating, but talk to me about the Rockham side of things and how you do that for performance for real workloads and not just benchmarks.
That's a great question. Ultimately, we have a slightly different experience and focus because we are AMD exclusive, right? AMD exclusive means we also need to be experts at helping customers get going on Rockham often, right? If we're engaging with a customer that has no experience with AMD, that's transitioning from NVIDIA to AMD, there's extra steps involved there. Now, to AMD's credit, they've done an excellent job making that much more seamless over the past couple of years. They've made great progress, and they continue to do so. But we often have to work very closely with customers to get their workloads, validate them on the Rockham stack, make whatever tweaks are necessary, and you'll account for the differences in architectures between NVIDIA and AMD. And while that gap is narrowing and the amount of work is lessening every day, it is an important aspect of our onboarding and our service with our customers.
That's fantastic. So once they're live, you guys want choice, right? You want flexibility. You want your data where it is. You want it to be able to reach global capacity. So let's talk about multi-cloud journey, right? Because that's the real situation we're in right now as we move to value and ROI. Enterprises are kind of reconsidering some of their decisions about the major hyperscalers, and this is why you guys are growing so fast. When you talk about service, agility, and limitations, let's start with you, Kyle. At what typical moment signals the customer's ready to move away from let's say, AWS or Azure? How do you know?
Yeah, I mean, I would say that move away to me feels, like a battle that we'll just lose head on. We don't have the resources of hyperscalers, and some of those products are behemoths. There's probably a really good argument to make that S3 is AWS's most defensible product and biggest moat they have as a hyperscaler. And so, we're always operating in a way of how can we supplement your workloads and give you access to hardware and quality support and make it a lot easier for you to manage that hardware. So, I think that products like SageMaker and Vertex come with a pretty good learning curve, and so the teams that go multi-cloud are looking for access to SKUs more easily, and they want the ability to move between those cloud providers quite seamlessly. And so that's the layer that we're focusing on. And in terms of when is the signal that someone is ready to employ a multi-cloud strategy, I think it can be kind of hard to get the attention that you need from the hyperscalers, depending on the size of your deployment. And what's big to a company may not necessarily be big to a hyperscaler. And so, for us, it's kind of tapping into these AI natives and DNBs that are at the bleeding edge of infrastructure and making sure that they get as much attention and access to hardware that the rest of our customers do.
Fantastic. So Derek, I know that you may be short on time. So how do you make hybrid plus multi-cloud feel seamless instead of like kind of patchwork? I know I'm giving you more of the tough questions because you talked about tuning and optimizing, but it can be difficult in patchwork, like this piece. How do you make it more seamless when you think about the TensorWave approach?
Yeah, no, that's a great question. In general, we're seeing multi-cloud and hybrid become a lot more popular, and we're very in favor of it. And the primary reason of that is we have a very strong focus on doing one thing and doing it very well. And compared to hyperscalers, compared to legacy cloud providers, they try to do everything, right? And so we do go out of our way to try to enable customers to do multi-cloud strategies because we want them to use us for the things that we are the world's best at. And we don't want them to use us for the other things. Right? Because we're not going to be the world's best at that. If you want to, run a CPU farm, we're not your cloud, right? We don't want that business. There are other more established clouds that can do a much better job at that. But if you want to run an AMD GPU cluster at scale, we are the cloud. And so we do go out of our way. It's usually more of a networking question than anything, being able to link to other clouds in a seamless way, set up the right kinds of VPNs, have a good amount of connectivity at telco hotels and on dark fiber to connect into hyperscalers and other clouds. That's usually what it boils down to behind the scenes. But we do, support and encourage customers to do that because ultimately we want them to have an overall excellent experience, be able to use different clouds for what they're uniquely, adept at.
Fantastic. So, Duncan, let's talk white glove. How much of a white glove onboarding impacts the workload and value play for Vultr?
No, I think it absolutely is a key part of the proposition, especially, by offering choice, we really give people a decision that they need to make. And for folks who have not been on the Rockham AMD ecosystem before. There definitely are some hurdles that need to be overcome in terms of migrating a workload. There's definitely benefits that we've seen, in kind of straight out of the box, not a synthetic benchmark, real life workloads that people have brought over that have seen very quick and rapid multiples of performance versus the other ecosystem. It's really a case where everyone's stack is different, everyone's orchestration is different, everyone's process is different. It's really how do you match with the customer to be able to help them bring that workload and be successful in their business. The way that I talk to my team about it every day is the only way we're successful is when they're successful. So let's make them successful so that we can move forward as well.
So with that, let's bring it all back to some tokenization, right? I'll keep it with you. Balancing price for your customer is always a tricky deal, right? Because you guys are paying billions of dollars to us. Thank you very much.
You're welcome.
So flexibility, real customer support. How do you do that sustainable ROI without it going, up and down and being lumpy for your business?
I think what it really is it's matching with customers and their end goals. This is a case where, those of us who've been lucky enough to live through boom times, you identify folks that truly have a defensible position in their marketplace, that understand the value that we bring to the table. There's lots of different options out there. This is not a one size fits all type scenario, and we feel that we bring something that has unique value proposition to the marketplace, our global scale, our capability to match, the needs as our customers ramp up. An example that I use, they're not a customer, so I use it as an example. We all remember a year ago, those ads for Fargo from Wells Fargo, assuming it's a generative AI solution, what did this take to ideate? What did this take to R&D? What did this take for a CMO to finally decide we're gonna spend tens of millions of dollars to advertise this? So being able to take that customer through that entire journey over the course of a year, 18 months, 2 years is something that we spend a lot of time working hand in hand with to be able to deliver the capacity to meet the workloads that make them successful in the long run.
Wow, that's fantastic. And there's a whole value chain there, right? And you have to consider that when you consider your price. To that end, Derek, tuning, even on that. And so tuning and speed to deployment, because obviously there's a time continuum for that, right? And customers bang on your door and they want it now. How do you balance that real tuning, utilization piece of it and speed to deployment?
Yeah, so the balance is actually quite simple. Customers do care about both, but they care about speed way more, right? The customer would definitely rather have a cluster that's at 90% performance today than wait a year for a cluster that's at 100% performance, right? And that math is simple. So we are always optimizing first for speed of deployment, always. How can we build the data center faster? How can we get the cluster stood up faster? But then once it is up, there's this ongoing work with the customer. Especially for the first couple of months, cluster deployment, bring up where we're really understanding their workload, figuring out things together, and that's the time when we're optimizing. But the first priority is always speed of deployment, getting to scale as quickly as possible, and then we work on optimization from there.
Fantastic. Kyle, so time to tokenization, how are you helping your customers?
Yeah, I want to kind of go back to kind of what our core tenets are for Crusoe and going into the next year, and we're betting big on inference. We have a hardware for diversification and a large deployment with AMD, and it's been exciting to really explore that as that turns up. But our bet has been on inference, and it has been on intelligent KV cache management, and it has been on ways to beat out VLLM and time to first token and get a highly performant inference stack out there in the market. And this is something we have coming in a matter of weeks that we're quite excited about. So performance is one thing, but time to market and general, just how quickly can we turn up data centers in a quality way back to our qualification and getting a well-oiled machine to get stuff out there and running reliably at scale.
So, that's great. Let's prepare to wrap. In closing, so another factoid, China just hit 1 teraflop of solar power generated. I believe that America runs on 500 megawatts or something like that. That's huge. They can power us twice. Opportunity for United States to get more efficient and generate more power. Obviously, you guys are looking for more power sources and alternative, sustainable. But what's going to happen in this next 18 months? Because that was a big aha. We didn't see that coming. In your views, yeah, we could keep it with you, Kyle. Like, what are we going to see next? AI infra.
Yeah, I mean, I think that if there's an area that I think is going to get the most attention, it's intelligent management of the workloads at the power level. The grid is in a horrible state, right? It simply cannot sustain the growth of the energy demand that's happening these days. And so flexible compute operations that can be able to orchestrate workloads around curtailment windows and in situations where grid providers are asking data centers to turn down total energy usage, that is job aware and workload aware, that is something that I think is going to be critical to be a part of any interconnection at any part of the country. And so couple that with stranded and sustainable energy sources like what we do with reclaimed batteries and whatnot. Like, I think that's generally the direction that all of it is heading.
So Derek, we're going to wrap. I know you have to leave. What are your thoughts on what we're going to see in the next big wave?
Yeah, absolutely. This is actually extremely topical. Power is the #1 constraint by far that we see in the industry right now. And our belief is that we are going to run out of power in the country way before we run out of demand for AI. Right? And this is going to be the main blocker, the main bottleneck for progress and for clusters being deployed. And so right now there's a race. All cloud providers are trying to reserve and lock up as much power as they can. But ultimately this will be a driver of innovation. People are going to have to figure out how to do more with less for some time until additional power generation capacity comes on in the US, which we're seeing that really, really ramping up in 2030. So between now and 2030, there's going to be a power constraint ongoing, and it's going to be challenging to navigate.
Incredible. Okay, Duncan, 30 seconds. What's next?
I think, on the power side, we all absolutely understand the constraints that's going to derive. Something that I've been saying for years is, as the hardware increases and the power draw continues to go up, we will absolutely continue to see efficiency get driven on the software side. So it's a case where these are not kind of only one direction. These are absolutely something that's happening in balance. Transformers is not the end software architecture. We will see absolutely new, other, more efficient ways to drive this. And, we will see the possibilities in terms of the outcomes of what these products can do continue to develop in that way as well.
So with that, we'll conclude this wrap. It's not, if there's one takeaway, guys, it's not about like bigger data centers. It's about more efficient ones that drive more tokenization, utilization, and more efficient. We got the heavyweights. Gentlemen, thank you. This has been fun. Crusoe, TensorWave, and Vultr all together for the common good.